Hello friends, welcome in this video. In this video, I'll show you how we can solve the recycle and purge. So here actually, this is about the feed tank. There is a reactor. This is condenser, and there is some. We find out some set values. So here actually, we will find out what purge flow rate. That means what the substitutes which we are purging out from here from this streams which is coming out from this condenser this one. So then some recycled flow rate. Then what is the mixed stream flow rate? Mixed feed flow rate. Then we can calculate here purge ratio, recycle ratio, and combined ratio. Okay, so for that we need some initial values. So we will give some initial values. So for that, from here, I'm just taking this is a cluster of data. So here, whatever be the minimum requirement of this problems we have, we will give you here. So, so this is your feed composition. What are the feed composition we have? So suppose I take this is one CO hydrogen, and next we are I'm taking inert. Okay. So this would be here. So I'll just keep it here. This is our composition in percentage. The same thing. Okay. So now this part is over. Okay. Now here we have to take your basis. Key, what is the basis? So basis feed flow rate. We are taking. Okay. Now this. Now we need what is the percentage conversion is going on. So that percentage conversion that should be inside the reactor. So I'll just keep it here. Now next will how much percentage in mixed feed. So the data, it should be here actually. Okay. Now I think whatever the basic data is required, it's over. Now we'll see how to find out all these values, purge flow rate, recycle flow rate, mixed feed flow rate, etc. So now here, go back to the background diagram, and from here, first of all, I'll just unbundle CH inert. Okay, good. And this is about the base, so I'll just take here. This is base, and whatever with this base we have. So according to that, we have to first find out the exact quantity of our feed. So for that, I'll just take, okay, I'll replace it removable pallets with this multiply. So from here, we need this is feed, okay, and this is a percentage composition. So the value is here. This is okay. So this is your give you quantity of zero. Okay. So now from here we can see. Suppose we are giving the value. This is at 32. This is 64. This is in percentage composition, and this is nothing but this is this is your and this value will enter here. So what we have to do, we have to copy this one and copy this one, and now this is percentage, and then again I multiply this one. Okay, now we'll check either it is working or not. So here actually, suppose I'm taking the feed. This is 100. So what would be the, okay, and this is zero quantity. Okay, so sorry, here we have to change into numerical palettes, and this is divide. Yes, and this is a 4. So now if I take this is a 1, then accordingly you can check here the value, quantity of COH2 and inerts will appear. So now after then we can do for further calculation. So now here actually we'll see. So this feed we are supplying from here, and some quantity is supplying is coming from the recycle and here mix. And here actually the composition of inert is given. This is suppose we are taking this is a 15% is given, or any percentage composition is given. So the rest would be your other components. So from here we can find out your other components part. So from here we can find out the other part. So we have this percentage mixed feed, and this percentage mixed feed will supply same from here. So this feed again subtract from 1. So now this is nothing but this is your rest components except the inert actually. So now this is the part from here we will see this is your CO and H2 in mixed feed. This CO and H2 in mixed feed, it will go inside the reactor. This CO and H2 in mixed feed will go inside this reactor, and this way. So that would be, if we'll run from here, as this is 85, if we talk in terms of percentage, then it would be percent CO in the mixed feed. So this is nothing but from here again I'll multiply 100. So Okay, so now this is 85% CO industry is mixed feed and 15% in inert. And here the reaction is we're taking some values of it is 20. So 20% reaction is going on. So here we have unreacted part of inert and S2. So we will calculate from here. So here first of all we'll see how the reaction is going on, and then we'll find out the unreacted part from here. So this is nothing but so 20% reaction is going on. So unreacted is percentage conversion. This one from here we can see how much reaction is going on. So so this is showing the reaction and unreacted part. So from here, if I multiply with this one, and this is percentage conversion is here. This is again, if you see here. So this is giving 20, and from here, and this is suppose until this is your unreacted CO and H2. So this is unreacted CO2. We'll see where is it. So that should be here. Okay, let me check how this value is coming. This is 0.68 of M actually. So okay, now this is the one part of unreactant, and another is your inert. This inert is also unreacted. So the total unreactant part, or we'll say from here, if you'll see, the unreactant part will enter into that and then will come out. So the total reactant, total unreactant which is come out from the condenser, this is we have to take both part, this one and another is this one. So for that, I'm taking this one and this and so this is your unreacted CO, H2 and inert. So this is so that will take out from here. So what is this value? We'll see this 0.83. So This is levered out from this condenser. So now from here we'll find out the mole inert gas level. So for that, here we can do what we can do. So find out mole percentage inert gas. So okay, so for that we have to do the calculation, and this is coming out, and this is so this is nothing but this is your mole percentage of inert gas leaving the condenser. So this mole percentage of inert gas, here we'll see. Yeah. So that should be the mole percentage of inert. It should be same here, here, and here. So let me check what this values is coming. So 0.1807. Okay, this is a percentage is coming. So this is not in mole percentage. So for that, what we have to do, so multiply this one and connect to this. So now this will give us percentage. Okay, right. So now this is given as percentage. So that means what, 18.2 something percentage mole percentage of inert gas. So now here we will now to find out how much parts is here. So for that we'll do the overall material balance from total input and this input and output here on inert gas. So here actually now apply the apply the inert inert balance on input and output. Okay. So for that we have this basis. So again multiply the basis, and we have inert composition. So this is inert composition, and this is divided by your mole percentage of inert gas leaving the condenser. So from here we can find out the purge flow rate. So that purge flow rate, from here we'll check how much this value is coming. No, this is okay. From here we'll see. Okay, this is some mistake. Feed and from here we'll find out how much inert we have. So that inert is nothing but this total. We'll check how much this value is coming and then we'll land it. Okay, so this is nothing but this is your value and that value it should be value here and this value we'll see how what this value is coming. So 0.04. Okay, right. So here actually there is no issue. If I take this 100, so it is a 4, and if it is coming 4, then this is coming. How much this value is coming? So let me check again. Okay, so go back. So from here, this is a percentage. So for that, it should be disconnected from here actually. Okay, now let me check again. So here we are getting this purge flow rate. So this purge flow rate, this is, and from here we can take this one and just remove and fix it here. This is flow moving for out. So from here we can able to find out this purge flow rate. So now we'll do this material balance at this point. So here we will, so at that point if we'll apply the overall material balance. So this is nothing but this is gas leaving the condenser, that would be the purge plus recycle, this purge plus recycle here. So now we will apply this material balance here and the gas leaving the condenser. So this is the gas leaving the condenser. This is a 0.83 of mixed feed. So this is nothing but of mixed feed. So this and total P and R. So from here again we'll rearrange. We know the value of the P. So from here we can easily get the value of R. That means recycle ratio. So how we can get? So this is, see here. So we have leaving the gas is this one. So what we have to do, the multiply. So this is your feed and now this is, so this is your 0.83 or we'll say from here whatever the total we have. So this is a unreacted COH2 and inert. So from here we have to write your one over material balance equation. So from here we can write this F is equal to, sorry, F plus R, that is equal to M. So so this F whatever will be your this we have plus R we don't know. So here actually I take this is addition. So this is what will be feed we are supplying, and from here we have R. So we don't know what is the R here, and this is multiply. This is multiply with this here, and then this is again I will take it subtract from this, and whatever we your P we have. So this P is nothing but this is P, and this is again divided by your value, and this is nothing but here again I take one subtract part, and in subtraction this is 1, and this is nothing but whatever we the moles of unreactant we have, and this is not divided, and this will give you recycled flow rate. So now here actually what we are doing here, we are simply solve both these two expressions, and then from here we'll find out this value of R. So now check what the value of R is coming. So wow, very good. This is coming negative, so there is a mistake. We have to find out. So where is it coming? So, and from here, this is, let me check what this value is coming. By 0.182, okay. So that's why it is doing some, okay. No, no, we have to mm, unreacted COH2 and inerts, this one, okay. So we have to multiply here, not with this one, unreacted H2CO2 is how much unreacted H2, and then it's unreacted CH2 and H2, this one, and that value should be, okay, I'll multiply from here, then let me check. Okay, once again, this is also the mistake here, because we have to connect with this one actually. Okay, now I'll check. Yes. So from here we can see again. I'll just remove this part. So this is your this recycling flow rate. So I'll just put it here. Okay, so that means what now we have, this is P R. So now we have to calculate your mixed flow rate. So mixed flow rate is nothing but, from here we can find out, this is R plus F. So R plus F, this is your R, this is your P, and for so this is from F, and this is R. So this is mixed fluid flow rate, and so again we'll check here. Okay, 358, and this is 100, so 158. Okay, so now we'll put it this value. It is coming here, and we are putting this one We are putting here this. So this is over, and this is over. Now we have to find out uh, purge ratio, recycle ratio, like that. So we do back here. Purge ratio, this is nothing but this is your P divided by R. So for that, this is P. So we have to choose this is P and this is R. So this is purge ratio. So here we will see what is this value. Okay, once again I will be running. So 0.06 something it is coming. Okay, go back here. So this is purge ratio here. Now similarly we will find out the recycle ratio. See, recycle ratio, this is nothing but here this is your R divided by F. So this is R, and this is a feed, this is feed, and now disconnect from here. This is your recycle ratio. So this is 58 something. So that would be here. So now next is your okay combined feed ratio. So for that, combined feed ratio, this is nothing but here what we are combining the two things. So that means here we'll see the ratio. This is nothing but this is M by F. So now M by F. So M, this is a mixed feed. We have already calculated this one. So again, this is M and F is coming from here. This is from here directly. I just take one connection and connect. Okay. This is combined feed ratio. So now let us check what it is. Okay. Now it's okay. That should be some here. Okay, so from here actually now we are able to find out all the missing data. So now here you can change any value, you can change any basis, and according to that we can find out the value there is here. No need to do the calculation again and again. So is it only for this video? Thank you. If you like it, then please share, subscribe with your friends.